Hello everyone. Welcome back to the channel. In today's video, we are going to learn about RCCB, Residual Current Circuit Breaker, in a simple and easy to understand way. An RCCB is an electrical safety device that protects us from electric shock and helps prevent electrical fires caused by leakage current. Leakage current is the unwanted flow of electric current from the live wire to the earth instead of returning through the neutral wire. Why is RCCB important? Protects human life by preventing electric shock. Prevents electrical fires caused by earth leakage current. Detects leakage current and trips instantly to disconnect the power supply. Improves electrical safety in homes, commercial buildings, and industries. Construction of RCCB, Residual Current Circuit Breaker. This figure shows the internal construction of an RCCB and the function of each component. Test button T, used to check whether the RCCB is working properly. When pressed, it creates an artificial leakage current. If the RCCB trips, it confirms that the device is functioning correctly. It is recommended to test the RCCB periodically once a month. Electronic circuit acts as the brain of the RCCB. Receives the signal from the toroidal current transformer, compares the incoming, live, and outgoing, neutral currents. If an imbalance is detected, it sends a signal to the trip mechanism. Trip mechanism acts as the switching mechanism of the RCCB. Receives the trip signal from the electronic circuit. Releases the latch and opens the electrical contacts. Disconnects the power supply immediately during a leakage fault. Contacts carry the electrical current during normal operation. Remain closed when no fault exists. Open instantly when the RCCB trips. Isolate the faulty circuit from the power supply. Toroidal current transformer, current transformer. The most important component of the RCCB. Both live, L, and neutral, N, conductors pass through its toroidal core. Continuously compares the live and neutral currents. If both currents are equal, no magnetic flux is produced. If leakage occurs, an imbalance creates magnetic flux, inducing a voltage that initiates the tripping process. Operating handle, used to manually switch the RCCB on or off, also indicates the current status of the RCCB. After a fault is removed, the handle is reset to restore the power supply. Terminals, line and neutral. Connection points for incoming and outgoing wires. The upper terminals are connected to the power supply. The lower terminals are connected to the electrical load. Ensure secure and reliable electrical connections. Working principle of RCCB, Residual Current Circuit Breaker. This diagram explains how an RCCB works under normal and fault conditions by comparing the current flowing through the live, L, and neutral, N, conductors. Normal condition, no leakage. Step 1. Current flows through the live wire. Current enters the load through the live, L, wire. Step 2. Current returns through the neutral wire. The same amount of current returns through the neutral, N, wire. Step 3. Current comparison. Live current, IL, is equal to neutral current, IN. Step 4. Toroidal current transformer. Both conductors pass through the toroidal core. Since equal currents flow in opposite directions, their magnetic fields cancel each other. Net magnetic flux is equal to 0. Step 5. Trip circuit. No signal is generated. Trip mechanism remains inactive. Step 6. Contacts. Contacts remain closed. Power continues to the load. Result: no tripping occurs. The RCCB remains on. Fault condition: leakage to earth. Step 1. Leakage occurs. Step 2. Current imbalance. Not all current returns through neutral. Therefore, IL is not equal to IN. Step 3. Toroidal current transformer. The difference between live and neutral current creates a net magnetic flux inside the toroidal core. This induces a voltage in the sensing coil. Step 4. Trip circuit. The induced signal activates the electronic trip circuit. The trip mechanism is energized. Step 5. Contacts open. The contacts open immediately. Power supply to the load is disconnected. Result: the RCCB trips instantly, disconnecting the supply and protecting people from electric shock. Types of RCCB: Residual Current Circuit Breaker. RCCBs are classified based on the type of leakage, current they can detect. Choosing the correct type ensures proper protection for different electrical installations. 1. Type AC RCCB. What does it detect? Detects only AC sinusoidal leakage current. Applications: residential houses, lighting circuits, socket outlets. 2. Type A RCCB. What does it detect? Detects AC leakage current. Detects pulsating DC leakage current. Applications: washing machines, computers, UPS systems. 3. Type B RCCB. What does it detect? Detects AC leakage current. Detects pulsating DC leakage current. Detects smooth DC leakage current. Applications: electric vehicle EV chargers, solar PV inverters, variable frequency drives VFDs. Applications of RCCB, Residual Current Circuit Breaker. RCCB is used wherever protection against earth. Leakage current is required to ensure the safety of people, equipment, and property. Advantages of RCCB, Residual Current Circuit Breaker. An RCCB provides reliable protection against earth. Leakage current, ensuring the safety of people, electrical equipment, and property. That's all for today's lecture on Residual Current Circuit Breaker, RCCB. If you found this video useful, please like, share, and subscribe to the channel for more electrical engineering lectures and interview preparation videos.